So today's video is about the Laplace transform and how we can use the idea of the Laplace transform to solve differential equations. So if we start with a quite easy example, y double prime, I'm going to use the prime notation, plus 7y prime plus 12y equals 0. And we're given initial conditions, y0 equals 0, y prime 0 equals 1. So first thing we do is take the Laplace transform of each of these on both sides of the equation. So the Laplace of y double prime plus 7 times the Laplace of y prime plus 12 times the Laplace of y equals the Laplace of 0 is just 0. Now we go to our formula sheet because we can see the Laplace of y double prime can be written in a different way. It's just s squared multiplied by the Laplace of y, take away s times the first initial condition, take away the second initial condition. Let's just simplify that a little bit. We'll let the Laplace of y equal big Y. And you'll see it's just easier to, so we don't have to keep writing that. So, but this is the Laplace of y. So s squared times the Laplace of y is s squared y. Take away s, y0 is 0. So that can disappear, we don't need to write that again. Take away y prime 0 is 1. Take away 1. So all that becomes that. And now we do the same for the y prime piece. So plus 7, and the Laplace of y prime is 7 times s times the Laplace of y, take away the first initial condition. And again, the first initial condition goes to 0, or is 0 rather, and that is plus 7 sy. So we've got s squared y, take away 1, plus 7 sy so far, plus 12 multiplied by the Laplace of y, which is we're calling y equals 0. Okay. This minus 1's a bit of a pain, so let's move it over to here. And then we've got s squared y plus 7sy plus 12y equals 1. Okay, so far so good. Take the y out. Y into y into s squared plus 7s plus 12 equals 1. So y equals 1 over s squared plus 7s plus 12. And we can write this in another way, equals 1 over, and I think you'll find it's s plus 4 multiplied by s plus 3. Okay, now we can write this using partial fractions, equals a over s plus 4 plus b over s plus 3. And if we multiply all of it by s plus 4, s plus 3, which is this, we get equals a multiplied by s plus 3 plus b multiplied by s plus 4. Okay. We could equate coefficients, or we could substitute a value for s in. Let's substitute a value for s. Let's let s equals minus 3. So let s equals minus 3, and that disappears, and you're left with 1, because we multiplied, equals b times minus 3 plus 4 is 1. So b is 1. And if we let s equals minus 4, that disappears. And then 1 equals 3 minus 4 minus 1 a. So a equals minus 1. So now we can rewrite this line, which is y equals, and substitute these values we just found. We'll start with the b because the a is negative. B, whoops, scrub that. B is 1, so is 1 over s plus 3. Take away, that's your minus 1 over s plus 4. And now we can go back to our table. Let me just move you down a second. And now we can go back to our table and find the inverse Laplace of each of those. And we'll find that is just, if you got this plus 3, it means it's e to the minus. So this, if we inverse Laplace this, it's e to the minus 3t. Take away e to the minus 4t. The inverse Laplace of y is y. And that is as simple as you can get it. So we'll give ourselves a tick and a VG today. And maybe a smiley face. What do you think of that? Not bad. We give him a nose, I think.